Hi, this is Laud Jensen from Best in Class. Today I want to try and pick up one of my old blog posts where I did Brian's brain simulation in a Swing UI and show you how to load that up in the new and very interesting editor called Lighttable. You've previously seen me do a lot of Emacs. I'm actually trying to make the full switch to Lighttable because it has a lot of interesting advantages, especially in terms of productivity. Then once we get that code running, I'll show you how to convert it to Clojurescript and compile it to JavaScript and actually run that from within an HTML file. So to get started, let's look up the old code in the original blog post. Which I put at the bottom. There we go. And so to load this in Lighttable, all you'll need to do is actually download Lighttable itself. Here we go. And it installs very cleanly on both Windows and Linux and Mac OS X. And then secondly, you're going to need to install Line in Windows. And djpowell.net has a very easy to use installer, which is very similar to the Line shell script that you use on Unix systems. And this will put the line command on your path, which we're going to be using in a second. For now, I'll just copy the code. Oops. And get a new project started. So we'll do a line new. I'll call this one Brian's Brain. And this will create the basic project structure, where you have your project CLJ and you have a source directory. The next step is simply to open up Lighttable, which might look a little bit different once you install it the first time. You'll have a welcome screen and so on. I just removed some of the bits that I didn't need to use, but you can always hit Command Space to get the command bar up, where you can do some fuzzy search and find whatever you need to start working on. In this case, we're going to add a folder, so that'll be the command add folder. And let's see, I created this under coding and blog post and Brian's Brain. So now that's loaded into our workspace tree, and we can get started on the source. It's already put a core file in here, which obviously doesn't do a whole lot. And all I'm looking to do is actually just paste the code in. We can use the namespace. And if I just eval this, the entire file, by hitting Command-Shift-Enter, Lighttable will look in the project CLJ and it'll start fetching dependencies, and it'll spawn a REPL, and it'll connect to the REPL, and you will have live evaluation. But you won't actually have a REPL window like you do in Emacs. Instead, you're going to be able to evaluate stuff directly in your code buffer, which is very, very nice. It also has watches that allows you to inspect values as the program is running. So, for instance, if I wanted to look at current, I could add a watch. Then I could run the main loop again by hitting Command Enter. And it's actually restarting. All right, yeah, I set the default close operation to exit on close, so that means that it actually kills the REPL once you close the window. You see now the window is running again. We have two windows running, so performance is suffering. But you can see the window running, and you can see the values actually updating live as we're going along. And this is extremely helpful, especially when debugging distributed systems or web services. You have data being sent from the front end, and you're trying to receive it somewhere in the back end, and it might go through some data manipulation routines and so on. And this lets you keep tabs on how the data is looking at every step of the way. So it's extremely helpful. But so now the trick is we want to port this to Clojurescript to run it in a browser instead. And to do that, we need to open up a new project, obviously. There's actually a Line plugin that helps us do this. Type line new MIS, and then we can call this the brain script. And what this does is it creates a structure similar to what you saw before, but it's geared for Clojurescript instead, so that means it's going to be pulling in some dependencies that we didn't have before. Folder again. There are a few annoyances with Lighttable. One of the things is the folder opening dialog doesn't remember where you're coming from, so you have to navigate from scratch every time. There are a few other things like dependencies, mixing between your project and Lighttable itself, and so on. But you know, it's work in progress, and it's still early days, but it's looking very promising. So this project contains a CLJS file, which is not very different from normal Clojure, but this compiled to Clojurescript instead. And the project CLJ will have some new stuff, like we have Clojure and we also have Clojurescript. And then we have this very helpful plugin, CLJS build, which allows us to compile the Clojurescript file. But for this project, we're only going to use it for the initial compilation, because once you have the initial compilation, you have generated the CLJS file or the initial JS file, you can actually do a REPL-like evaluation where you evaluate directly to the browser, which is very, very helpful. So, but the things to notice here is we have a source path, which of course matches where it put the core file. We have an ID for a project, the source path, and then we have an output directory. In this case, we're going to put everything in out. And then we have an initial index file, which we can use to look at the actual HTML. So to get this started, there's one library that's not added here, but well, one that I found to be very helpful when working with the DOM, and that's Domina. I think that's on version 102 right now, so we can pull that in. And then actually Lighttable itself has some integration that you need to put in as well. I think it's called line light nREPL, like so, and I think that's on 0018 or something like that. And this actually goes as a plugin, I think, for the line command line stuff. So we're going to do line light nREPL here as well. And then finally, it also goes as a REPL option, where you have some nREPL middleware. And the middleware is just calling Lighttable, nREPL, handler, and then Lighttable ops. I hope I got everything right. So we're going to save this, and then we can try and do an initial compilation of our CLJS file. And the way we do that is simply to do line CLJS build once. See what I got to save anything? Nope, we're good to go. So it's looking up the source directory, and it's hopefully finding the core file and compiling that and putting it in the out directory. Yep, we got it with 0 optimization. So I could probably do a follow-up blog post where we try to optimize the code really heavily for the new host, but for now it would be good just to get it running. To do that, there are a few basic steps that we need to take in order to get our development environment set up correctly. Number one is to get our dependencies compiled so that we can reference them from the HTML file. Secondly, we need to load the HTML file and connect it with our code buffer, and that'll make it a lot easier to see whether our rewrite from Clojure to Clojurescript is successful, because we can evaluate every step along the way. So far, the only dependency here is actually Domina, so we'll go ahead and require that Domina as Domina, and we'll run the CLJS build once again, and that'll put all of the dependencies in the out directory. Then I'll write the HTML file, which basically references the dependencies as JS files and connect it. And writing out the HTML is a little bit tedious to look at, so I'll cut the video. I'll be back in a second with an HTML file and a recompiled project. Alright guys, here's what happened while you were away. I ran line clean, which the documentation says will clean out any files produced by line itself. That turns out to be incorrect. It actually cleans out everything in the out directory, including the index HTML file that I moved in there. So I've just gone back to the original one created when I created the project. And what I've done is I've loaded all of the dependencies. When I ran line clds build again, it produced the out directory folders and files, and all of these needed to be loaded, so they're referenced here. Then I added a canvas in the body for the rendering itself, and then I referenced my own code. And then I guess most importantly, you have to add this line which connects your code buffer to the web browser window. And to get this line, you open the command tag and then you do a script tag, and you'll simply just cut and paste this. Annoyingly enough, the port changes every time you open live tables, so make sure to refresh this in your source code whenever restarting light table itself. But anyway, since this is done, I can simply save the file and hit Command Enter to eval. Just make a new tab set, and that gives me the clean canvas with all the dependencies loaded. And that'll allow me to go into my CLDS file and hit Command Shift Enter to evaluate the whole file, and it will establish the connection, and it will hopefully display some inline evaluation of each line here, just to let us know that everything is working. Just give it a sec. There we go. Okay, so the namespace is going to generate an error when we're doing interactive development because it was already defined when we loaded the file. So we can just remove that, and I hope that at some point these will be automatically suppressed. The enable console print command ran, which means that it's going to be able to print down here. So the next line, print line, hello world, prints the console. And I added a line for getting a reference to the canvas itself, which we're going to be doing the painting on, and as you can see, that returns an HTML canvas element. So everything seems to be up and running, and we can start converting the app itself. So we'll just paste the code from the original blog posts and walk through it. Initially, we had the imports from JavaX to get the Swing UI and also the color library, but since JavaScript doesn't have a hook into the JVM, none of these are usable. We're going to stick purely with JavaScript libraries. Then we have some definitions here. The dimension of the board, which is just the size of cells that we want to be working with. No changes needed, I think. No, we get an array, 9090. Then we have the screen, and this was used to produce the Swing UI and set it in the dimensions that we wanted. Obviously, when we're working with HTML, the dimensions are not going to be static. So what we're going to do is, since we have the canvas element, just make a reference. And the canvas was domina by ID and then my canvas, which was the ID I gave it over in the HTML file. And once we have the canvas, we can go ahead and just grab the properties of that canvas. So this would be the width of the canvas, and then we would also need the height property of the canvas. And that gives us the actual dimensions. The next line here is just the scale, and obviously this is going to work as well since it's just pure Clojure code. Then we have a forced map here, which is also pure Clojure, so that should work just fine. Then we have the function for rendering, and obviously rendering is going to see some changes because we don't have the Swing UI anymore. So we'll just have a read to see. We don't have the graphics, but we do have the cell. And obviously we can't write to it in the exact same way that we did when we were using Swing. So we're going to be using a graphic 2D context. Just go ahead and define that it's a context, and primary context, that's going to be context, and this is just pure JavaScript from the canvas. It's going to be 2D. There we go. And then the way to work with that is we're not going to be able to use due to here, but some of the functions are actually very, very similar. So I think set color is is actually called fill style when working with the canvas. So we'll use the set function to set variables in JavaScript, and we're going to set it for the fill style property of our context, and the rest should actually be the same except the colors. These were from Java ABT, so instead we're just going to use strings. So something like this for gray and something like this for white, and then that should be fine. And fillRect canvas actually also supports fillRect, but we're going to have to call it on the context, and the rest should be similar. Yeah, so not too many changes there, and the value is just fine. I'm just hitting Command Enter at every turn. The render function itself, it's not gonna take an image. I think we're gonna do it just, we need the context, and then we need the stage. So again, set color now is called fill style. So we're gonna set the fill style property for the context, and we'll simply set that to a black background. Exactly as before, fillRect for clearing can be used, and we're going to call fillRect on the context and fill the entire thing. A couple of double F maps here. All we need to do is actually change the names, the variables. Everything else should be fine. And then the draw image is, we could use it if we're going to do double buffering, but for now let's just try and get it up and running. Try and evaluate. Seems to be working fine. I'll just remove the workspace here because it's taking up a lot of space. Then we have the board itself. This is pure Clojure core, so no changes needed. We have the active neighbors, same. Torus window, same. The rules, also the same. The step is also pretty much the same. One big change here is that part of the reason for demonstrating the purely functional Brian's brain was to do parallelization. And obviously JavaScript is single thread, so no amount of trickery will get us any more threads going. So we'll simply change this to a map, and this is of course going to create a performance, but that's probably the topic for a future blog post. Then we have the activity loop, and that's pretty much going to go away. And then we have the Swing UI initialization and so on. That's also going to go away. So basically what this should give us is we can still do the stage and let that be an atom of the board. And you'll see the inline evaluation gives us some sort of view into what goes into that. So it's just as before, we have the state and then we have the coordinates. So I think we could actually try and call render now with the primary CTX, the context, and then the stage dereference, and that gives us the initial rendering of the board. And so to step this, all we really need to do is just call swap, and everything works exactly as in Clojure, and then just pass in the step function, and we should see the next iteration, and so on and so on. And so obviously in JavaScript, if you want to put this in some sort of loop, I'm going to do a main loop, take no arguments, and we'll simply pass in this function call. And I think that should be enough. And then JavaScript has a few different mechanics for running loops, but for now we can just do JavaScript set interval. And I think that takes a function and then a number of milliseconds in between. So this will give us 2 FPS, which is horrible, but it'll probably work. And actually, to be able to cancel this, I just need to save the reference. So we'll call this a thread, even though it's not. And we'll try to kick it off. Yeah, and we see the window animating now, so everything is running. And to kill it again, we just call JS clear interval and then kill the thread. So as you can see, sometimes when you're not working with a lot of Java libraries, converting Clojure code to Clojurescript is extremely simple. It's a very fast thing to do, and it allows you to do, all kinds of distributed computing, distributed systems, and actually outsource a lot of the computations and so on that you, in this case, earlier would have done on the server. This makes it a lot more scalable because we're passing out the work to all of the browsers that are looking at this page. That's it for now. Thanks for watching.